this game, this sort of pedagogical device, I'm going to define adaptability as just what I'm going to define it as. Okay, so assume that, for the example, adaptability increases as the number of positive analogical relations increase. So what are we saying, right? We're saying if we have a group alpha and we have a group beta, that alpha and beta are more adaptable as, let's say, segments or species within a region. So you can imagine that we have, let's say, a region. We have alpha that populates that region. We have beta that populates that region. And these two things, species, whatever they might be, these two things, alpha and beta, are more adaptable. They can sort of cohabitate, right? They're more adaptable insofar as they share, right? Insofar as they share positive analogical relationships. So the more things that they share, the more adaptable they are. So just before I move on to question number one, let me give you an idea. If we have, let's design two examples. So that's example one. This is example one, and then here will be example two. So imagine that we have this. This is beta, alpha, beta, alpha. Okay, very simple example. Let's say we have P1, 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 P2, 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 and we'll say P3, P3, and then we'll do this, and we'll do it like this. Okay. So let's say this is what we have, right? These two, we're assessing only the relationship between these two and only the relationship between these two. We're not comparing any member from this set with members from this set. We're not. These two we're looking at, these two, obviously a lot of this could apply to sort of preconceptions of set theory, right? You can use this is why I said it's not a logical or mathematical or statistical analysis, critical thinking. This has applicability all over the place, right? Now, I would say that with respect to what I'm identifying as adaptability in this example, just theoretically speaking, is assume that adaptability increases as the number of positive analogical relations increase. So the more two groups have in common is the more adaptive they are. Well, how many things do they have in common here? This has P1, this has P1, so that's 1. This has P2, this has P2, so that's 1. This has P3, this has P3, so that's 1. So we have 3. 3 properties that they share, so their adaptability is on, let's say, a scale of 3. This has P1, this has P1, so that has 1. This has P2, this does not have P2, so we would say that this has one positive analogical relationship that they share. Right? This has 3 analogical relationships that they share. So we would say that this group, for the example, is more adaptive than this group. Right? Whether this actually means something in science or not is not any concern at all of mine. I could care less. What I'm saying is I want you to understand that what we've done now, the point of this is to show you the following. We have taken the pattern and we've taken the idea of analogical relations and we've applied that relationship format to a concept. That's what's important, right? What we've done at this level, which is a much deeper level, but still very basic, is we've taken the analogical, explicit, empirical relations and applied that to a concept, the concept being adaptability. So that now we can talk about the concept of adaptability between two groups, alpha and beta, and we can say that alpha and beta in group 1, let's say this is group 1, is more adaptive than alpha and beta in group 2 based on a shared positive analogical relation of 3 as opposed to a shared positive analogical relation of 1. So that's the point. And if you get that, then we're good. Okay. So, with that in mind then, let's now look, and I think that should be very clear. Let's now look at question number 1. First question. if adaptability increases as the number of positive analogical relations increase, which group is the most adaptable and why? Right? If adaptability increases as the number of positive analogical relations increase, which group, right, and I mean groups from alpha, beta, gamma, delta, which group is the most adaptable and why? So I probably shouldn't have erased that. I'll leave it up on the board now. So let's redraw our groups. 1, 2, 3. Alpha, beta, gamma, delta. Then we put P1, P2, P1, P2, P3, P3, P1, random, random. Okay. The answer is sort of obvious, right? If I'm saying just pick one of the groups, right? Just pick one of the groups, right? So we have alpha as a group, we have beta as a group, delta as a group, gamma as a group, delta as a group. Which group is the most adaptable and why? Just select one of it, one group, and explain why. It's easy to see. It's easy to see, right? This group has a potential to adapt twice. This has a potential to adapt twice. This has a potential to adapt twice with respect to varying degrees. But what we end up seeing is, well, beta can adapt with alpha positively. It could adapt with gamma positively. It can adapt with this group positively. It could adapt with this group positively. And there's only one thing that delta could generate that it would not be able to adapt with, which would be another random property generator. So obviously the answer is beta, right? Beta is the most adaptable group, right? Precisely because it can adapt with more groups than others, right? This has an adaptability with P1. It has an adaptability with beta. But with respect to properties, we have to recognize that the relationship in gamma. Well, how do we go about making sense of that, right? There is no P2 in gamma, right? So it's going to limit its level of adaptability, right? It's missing a P2, so it's going to limit its level of adaptability. So pretty simple, right? Pretty obvious. All right, so that's number one. Number two, I'll write on the board. Can adaptability, here's a more profound question. Can adaptability decrease, right? Can adaptability decrease with a decrease in negative analogical relations and why? That's a pretty hard question, right? Can adaptability decrease, right, with a decrease in negative analogical relationships? So as negative analogical relationships decrease, how does that affect adaptability? So imagine this. Alpha, beta, alpha, beta. If there's P1 here, P1, P2, P3, and this is all that we have, well, insofar as this number decreases, right? So we have a decrease in negative properties. Decrease in negative properties, right? Can adaptability decrease with a decrease in negative relations and why? This is a bit of a trick question, right? Because it could potentially, can adaptability decrease with a decrease in negative analogical relations and why? It could potentially decrease, right? It could potentially decrease with, and this is why critical thinking is difficult. You really have to work through this, right? Can adaptability decrease, right? Meaning that it would be less adaptive with a decrease in negative analogical relations and why? Yes, it could, right? Provided that if I remove this, P2, if I remove that, well, the level of adaptability has not been affected. Right? If I remove that,